the elusive neutrino, a fundamental particle so small that for years scientists believed it had no mass. After a tiny amount of mass was measured in neutrinos, Japanese and Canadian physics researchers set out to learn more about their fascinating properties. University of Regina physics professor Mauricio Barbi explains.
Neutrinos, they come in three different flavors that are called tau neutrinos, muon neutrinos, and electrons neutrinos. So in principle there are three different things, but the fact that they have mass allow them to actually oscillate into each element. So one can transform into another one, so they can change flavor.
The Tokai to Kamioka, or T2K particle physics experiment, is based in Japan. The experiment will begin with a beam of protons colliding with the target to produce secondary particles called pions, which then travel through a tunnel.
Then as they travel, they decay because they have a mean lifetime. These guys, when they decay into different particles. Some of the particles are called muons. So when pion decay into muon, it also necessarily, due to some physics laws, it produces also neutrino.
Professor Edward Matthey is part of the U of R group which contributes to the fine-grained detector system. For this detector, students prepare optical fibers used to track light energy left by different particles. The hardware installation is almost complete, but the results will take a long time to measure.
For example, if a particle that arises from a neutrino interaction passes through an element of the FGD detector, then it's going to leave some energy behind in that detector. And we need to be able to look at the electronic information that we have to be able to figure out how much energy was left in each of the literally thousands of detectors. And we'll put that all together to have a picture of the interaction one at a time.
With a better understanding of neutrinos, he says the standard model of physics may change entirely. But for him, challenging prominent theories is not the most intriguing part of this research.
In general, that very subtle appreciation of how nature works is only something that you find in physics.